Okay, 10.5b, distance and midpoints. All right, so today we're going to try to find distance. And actually, we're just going to do distance today. We'll save midpoints for 10.5c. But so today we're just going to do distance. So on the coordinate plane, you can use either Pythagorean theorem or the distance formula to find the distance between 2 points. So you can use either of them. Sometimes it's easier to use one or the other, so we'll kind of go through these. But let's do a little Pythag review because I think it helps us to find distance if you can use it. But again, it only works for right triangles. We know that. The next thing is that A and B are the legs. They're the ones that form the right triangles. So say A and B, these are legs. They actually form the right angle. We know it's a right triangle because of that box there. That kind of denotes it. The other thing is C is the hypotenuse. That's this part over here. That's the hypotenuse. And finally, the formula here, a squared plus b squared equals c squared is the formula. Okay, so let's go ahead and find the distance between k and L using the Pythagorean theorem. So if we graph these real quick, you got k at -2, 0. That's right there. And you got L at 1, +4. That's right there. So if we drew a line between those, it would be like here. Okay. So finding the distance, one thing we could do is I could make a right triangle if I just draw a straight line here from point L down here, and then another straight line across. Let's just label that point M. So if I did that, I do have my right angle because I just drew a straight line down and a straight line over. Now, because it's a straight line, I could actually count the distance. So from L to M, it would be 1, 2, 3, 4. And then over here from K to M would be 1, 2, 3. So now I can use Pythagorean theorem to find this distance between K and L. So if I do that, remember it's a squared plus b squared equals c squared. So the legs are a and b. If I use, say, 3 squared plus 4 squared equals c squared. Now I can do the math. Squaring things, I would get 9 plus 16 equals c squared. 9 plus 16 is actually 25, which equals c squared. And now I just know that I have to take the square root of both sides. So c would equal 5. And that's what our distance would be. So that's one way to do it. Okay? And I like that way if you can use it. Sometimes you have to graph it and draw a right triangle with it, but that's fine. Let's skip over this one and go to distance formula. All right, so distance formula. This is the distance between 2 points, x1, y1, and x2, y2. So what is the distance formula? It's another way of doing it. You have d equals, d for distance, and the square root. It's a giant square root. Giant square root with x2 minus x1 squared plus y2 minus y1 squared. And just think about it this way. This x1, y1, this is your first point. First point. Okay? And that's why you have x. It's an xy coordinate, just your first point. And over here, your x2, y2 is your second point. Second point. So it's an x coordinate and a y coordinate of your second point. You just plug in those values into this formula, and then away you go to solve. So let's do an example here. Let's try this one here. Okay, find the distance between the 2 points using the distance formula. Okay, so if I just draw the line here between these two, okay, there we go. Now you could actually do the same thing and use Pythagorean theorem. Draw a triangle here to here and use Pythagorean theorem, or you could use distance formula. Okay, you could use the distance formula. So what we can do is use our distance formula here. Remember, d equals square root x2 minus x1 squared plus y2 minus y1 squared. So now we're just plugging in values. So if we look, if this is my first point, we can label this our first point. So this would be x1, comma y1. And then over here would be my x2, comma y2. So I have my points labeled. Now I can just simply plug those values in. So I got the big giant square root. What's my x2 value? Well, my x2 is over here. It's 3. And then I'm going to subtract my x1 value. Well, that is a negative 5. So it's going to be 3 minus a negative 5. And so you know what's going to happen is with two negatives. I'm going to ask you that. It's going to make a positive. Okay? Then we have to go ahead and add here my y values. Well, my y2 is 2 minus my y1. What's that? What's over here is 6. 2 minus 6. And we're squaring both of those. So now we just have to do a little bit of math here. So, simple math though, we can all add, subtract, square things. 3 plus 5 now is 8 squared. And then we've got 2 minus 6. So that's going to be a negative 4 squared. And now we know, of course, when we square these things, we're going to have the square root of 64. And negative 4 squared is going to become a positive 16. Remember, you square a negative, it becomes positive. So now we add underneath the radical, and we get the square root of 80, which then I'm going to need, a calculator to do the work there. I could break this down if I wanted an exact answer. If I wanted an exact answer, I would break this down and say that would be the square root of, say, 16 times 5, where that becomes 4. So we could say 4 times the square root of 5. That would be our exact answer. And if we wanted to do a rounded answer, we would just punch in square root of 80 into the calculator, and we'd get about 8.9. That would be our rounded answer. Okay? So just plugging in those numbers and going that way. All right. Let's try another one. Let's skip number 4. Let's go to number 5. Okay, from here on out, look at the bottom. It says, from here you can use either Pythagorean theorem or the distance formula, whichever one works best for you. So sometimes you're going to think, hey, if I graph that, I can easily make use of Pythagorean theorem. I think Pythagorean theorem is easier, but you have to graph it. So let's do one more with the distance formula. There's no graph here, so we're just going to say x1, y1 is there, x2, y2 is here, and we're going to go ahead and solve using the distance formula. So I'm going to say d equals big giant square root x2 minus x1 squared plus y2 minus y1 squared. And again, you're going to be using this a ton in geometry, so it'll kind of help you out to learn the formula now. All right, x2 minus x1, so we're looking at 5, and then x1 is minus 7, so it's a negative minus a minus 7 squared, plus y2, what's y2? It's 9, minus y1 of 0 squared. Okay, so now doing the math underneath the radical here, we would say d equals, well, the two negatives make a positive, so it would be 12 squared plus 9 minus 0 is 9 plus 9 squared. So really, we've got the square root of 144, because 12 squared is 144, plus 81. Therefore, distance equals, we add those up to 25, which as a square root goes to 15. 15 would be our square root. Okay? So from here on out, you can use either one you like, but those are a couple instances of the distance formula for you. On a number line, let's check this out. Distance on a number line, pretty simple stuff. When you find it, let's say you have the coordinates a and b, it could be any letters. Basically, you are going to take b minus a or a minus b. You just subtract them in either order. It really doesn't matter. And then you take the absolute value, or in general, what that means is you drop the sign. Okay? So if we wanted to find b to e, well, here's b sitting at negative 6, right? And then here's e over at 2. So if I want to do that, I could go the absolute value of negative 6 minus 2, Or I could actually go the other way and say 2 minus a negative 6. Remember, absolute value is going to be the distance from 0, so it doesn't matter which way you're going. So in this case, you're going to have the absolute value of negative 8, which is 8. And over here, you're going to have these two added up and be the absolute value of 8, which is also 8. I'm just going to drop the sign. Remember, it doesn't matter positive or negative. It's the distance from 0, so you drop the sign. It always becomes positive. Another way you could easily do that is to just go and count them from B to E, since we're going from B to E. 1, 2, 3, 4, 5, 6, 7, 8. 8 steps. So horizontally on a number line, it becomes pretty easy to find the distance. Okay, that does it. Let's go to the lesson summary here. Which method of finding the distance between points seems easiest to you? Why? So I know some of us are going to say Pythagorean theorem because you don't have to do all that squaring and number stuff, and the other people are going to say distance formula because you don't have to graph it with Pythagorean theorem. You kind of need to graph it. And in the practice problem here, find the distance between these points, negative 1, 4, and 1, negative 4. And tell you what, put a star next to the top of your notes at 10.4b, right where it says 10.4b, and that way I'll know if you were paying attention or not. Actually listening to the volume. So put a star next to your notes at the top of 10.5b. Okay? That does it here for distance formula. And bring some questions. We'll talk to you later.